You read the title or saw the thumbnail. We're talking about how your cell phone works. This video, by the way, is part of a series on how your phone works. I recommend you watch all the previous videos to fully understand this one. But before I get into anything, I gotta give credit where credit is due. Thanks Reddit user Brick Tamlin for the suggestion, and I hope this helps. And for this video, we're gonna be talking about the shell, glass, touchscreen, and battery all in your phone. Many phones on the market are water resistant, dust proof, and have that glass that doesn't break every single time I drop it. But how do we do this? Well, water resistance is actually pretty simple. Buttons and ports would be places for water to get in, but manufacturers place glue all the way to the back of the ports where water could damage the phone. And for buttons in certain ports or other places where glue would be visible and sort of ooze out and just not be good, there are little rubber rings that we can place underneath these special areas. And as you would expect, they block water from entering. And other tricks involve tape and silicone gels. But you can't tape, rubber, gel, or glue over a speaker, otherwise it would just be muffled and you couldn't hear anything. Well, for speakers, they actually use a mesh that is super small so that when water hits the mesh, it just kind of rolls off. Some manufacturers also use materials that are just water resistant to cover up the speaker, but they make sure that these materials can still let the sound out and won't block up the speaker. But how does your phone's glass get so strong? Basically, when they make glass, they take pure sand and a proprietary blend of other materials, and they melt these two together to produce a glass called aluminosilicate. Now, aluminosilicate isn't actually that special. It's basically the same as regular glass in terms of strength, but it reacts to the next set of chemicals way better. So this new glass, the aluminosilicate glass, will be dipped in molten potassium. This potassium switches places with sodium in the glass. Now this sodium comes from the proprietary blend from earlier. And this new potassium, the one that just came in, is larger than the sodium. So it pushes inside the glass and creates pressure, or more specifically, compressive stress. Basically, this means that there is even stress in the glass, which prevents flaws from forming. Now, to make this easy to understand, here's a little demonstration. Alright, so here we have an egg. It's actually a very nice egg. I might actually eat it if I didn't have this experiment. What's important is that there are zero flaws, and it's actually very much like the glass in your phone. It's actually not a flaw, it's just a small imperfection on the egg. It's not a flaw. But if I were to squeeze this very hard, very, very hard. I'm actually squeezing this so hard, my fingers are shaking a small amount, but it's not doing anything. I'm squeezing it very hard, and nothing's happening. And if I just put a very small crack, just a, right? Barely even see that. The minute I squeeze it, watch what happens. Gorilla Glass is also so strong because when it breaks, it doesn't break in shears and shards, which are basically just more flaws. Now for an essential feature of phones, touchscreen. The basic idea is that there is a sheet of glass with a grid of really, really thin lines of conductive material like indium timoxide. Now, the grid lines in one direction are the driving lines, which always have an electric current running through them. The lines running in another direction are called the sensing lines, which detect this electric current. When the two lines cross, it creates a neutral zone in the electrostatic field. Then, when you touch the screen, because of the conductivity of your finger, it distorts the field. In other words, because your finger is not neutral, it makes the field of your glass drawn around it. This means that the electrostatic field is not going through your finger, it just gets attracted to it. This local change in the field of where you touch is measured by your processor. So if you imagine this comb is your finger, and that this water right here is like your touch screen, then watch what happens when I bring the comb near it. It attracts it. Now, of course, there would be some glass right between the two so that they never even touch, but you can see that it makes it move. It or at least bends the field a little bit. And this bending is what your processor can sense. But how do we get power to this whole device? Batteries are fairly simple. Take two metals, dissolve them partially in a special liquid that allows for electrons to be deposited or withdrawn. And make sure one of these metals really wants to give up its electrons, and the other really wants to take in some electrons. Now make sure that these metals are not dissolving in one big container, otherwise they're just gonna balance each other out inside of the special liquid. Instead, put a small wall to block the flow of electrons between them. Then connect the two metals at the top with a wire. This allows for electrons to flow through the wire to balance out the two metals. And a flow of electrons through a wire is electricity. Yay, my battery's working! But to get power to your phone, you have to put it in the wire so that the electrons or electricity goes through your phone. Kind of important. Now, when the electrons balance out, when all of the electrons move from one metal to the other metal, the battery is out of charge. And when you recharge your battery, you just force the electrons to go back to the other metal, back to where they came from. Well, that's it for the video. The next video will be about your camera and microphone and speaker. Well, life is an experiment, and you are the scientist. Thanks for watching. Bye. And have that glass that somehow doesn't drop every single time I drop it. Did I say break? And a proprietary blend of other. Okay, that was interesting. Have that glass that doesn't drop lines of conductive material like Indian tin oxide. Indian. And the other metal really wants to take in some electrons. Now, okay, I just hit my mic. Did you see that? I just went boom, and I bet you that made a really nice, loud noise. And have that glass that doesn't always drop when I break it,